Make a video for this one. So let's graph a hyperbola. I'm just going to make one up. So here's our y-axis right there, and then we'll get another y-axis right about there. And let's do our business. No, did I say another y-axis? Okay, an x-axis, another axis. Let's just keep the center at the origin. Just keep it simple, and then we'll go out to our vertices. We'll go 1, 2, 3 spaces out to our vertices. So I'll put my vertice there, and 1, 2, 3, put my vertice there because I want this to be a horizontal hyperbola. So there's one vertice, there's the other vertice. Now let's start writing our equation since we have some stuff to write about. So we know that it equals 1. And it has two fractions that are subtracting from each other. Now before I know anything else about the hyperbola, I know that right here, the major, that's where we have the major squared. Now remember, we're calling it major squared, but it really has nothing to do with the major axis, because there's not a major axis for the hyperbola. But there is a transversal axis. It goes from here to here. And then we know that this one is minor squared. Okay, the question is, what goes up here and what goes right here? Well, you guys know that this is a horizontal. It's a horizontal hyperbola. So, what's going to go right there? Yeah, so we're going to put x squared there. X squared has to be positive if we want to have a horizontal hyperbola. What's this one going to be? Oh yeah, obviously. And it's just x squared and y squared because our center is at 0, 0. All right, now let's figure out these two bottom numbers. That we got the major squared and the minor squared. I want to get rid of the major squared right here, and we'll get rid of the minor squared right there. All right, so do we know one of these numbers? Do we know this number down here or this number down here? Do you guys know it there? So it's what? Well, close, but we need to know this right here. One. Oops. Where? This right here, 1, 2, 3. That's our major, and so we're gonna put 9 right here because it's major squared, right? So it's 3 times 3, we get 9, and then we need this number right here, which comes from when we get to our co-vertices. Now again, we don't have co-vertices in the hyperbola. It just kind of helps us learn it because you guys learned the ellipse first. So let's go 5. 1, 2, 3, 4, 5. So there's 5 spaces. We'll put our co-vertice right there, CV, and then you got to go the other way. You know, just go opposite way. 1, 2, 3, 4, 5, and we put a co-vertice right there. Let's see. And once you have your co-vertice, then you can draw your magic box. But before we draw our magic box, do we know the number that can go right here now? This was 5, right? This length was 5 right here. So what goes right here? Yeah, 25 goes right there. So I put 25. Look, we already have an equation, and we didn't have to like finish it. But I do want to finish it because I want to talk about some other things like the asymptotes, and I want to talk about the foci. So here, let's draw our magic box. It's not really that magical. It's just kind of like, why are we drawing a box? Because honestly, the only thing you need about this box are the corners. You need these corners right here, because you're going to use those corners to draw your asymptote. And so the asymptotes should pass through those corners, through the center point, and then they act as boundaries for when you draw your two parabolas for the hyperbola. So let me draw the other one. And let's again pause from doing the rest of it and figure out how do we find the equations for the asymptotes. Now these are both lines. Like this is a line right here, and this is a line right here. So we're going to use a linear equation, and the one that is easiest to use is the point slope form. So we're going to go y minus y sub 1 equals m times x minus x sub 1. You guys remember this stuff from Algebra 1? Hope so. I mean, it's important. So here you have point slope form, and we're going to, let's do the positive line first, the one that goes up. So there's two things that we need. We need a point for the x1, y1, and we need a slope for the m. So let's pick an easy point. Let's pick the center point right here because it's 0, 0. In fact, you should always probably try to pick the center point because, trust me, it'll make your life easy in the end. I'm going to show you. So we'll pick the center point, which is 0, 0. So we have y minus 0 equals m. Let's not write the m. X minus 0. Okay. Now, what's our m? Do you guys remember how to find that? You count the slope?
I do.
You just need 2 points. Good, I'm glad you do. So we have, I'm going to pick these 2 points, this point right here and this point up here. And I'm going to count up, 1, 2, 3, 4, 5. I always like to count the rise number first. So the rise number is positive 5, so we're going to put 5 right there. And then we got to count the run, and so we go 1, 2, 3. So our run is 3, so it's 5 over 3. And then when we simplify all that, we get y equals 5 over 3 times x. The zeros don't really do anything there. But that's my linear equation for this positive line. Now if I were to find the negative line, let's do the same process. Let's see, we'll go y minus y sub 1 equals m times x minus x sub 1. So this is point slope form. It shouldn't be that new for you guys, just to be a little reminder. Some of you guys should be going, oh. We use the same point because this line goes through that point. So let's use the same point. Just kind of stay consistent here. So we have y minus 0 equals, and that, you know, the middle point is 0, 0. That's why we put a 0 there. Minus 0. And then now we just need the slope. So to find our slope, I'll pick this point right here and this point right here. So I'll start right here, and I'll count down. And I get 1, 2, 3, 4, 5. So what's my rise? What's my rise number? Yeah, negative 5, because we went down 5. And then after I get down there, I count to the right 3. 1, 2, 3, and that's a positive 3. So I have a negative 5 over a positive 3, and that simplifies to y equals negative 5 over 3 times x. Now, what's the difference between these two equations right here? They're almost identical, aren't they? They're almost identical. The only difference is one of them is negative and one of them is positive. And what's cool is that for asymptotes of a hyperbola, it'll always end up like that. They'll almost be identical. As long as you're picking the center point, the slope will have the same numbers, except one of them will be negative, one of them will be positive. Which is why we like to write our asymptotes like this. Y minus k. K is the y for the center point. So y minus k, and then m, no, actually not m, plus or minus m, right, because it's positive or negative, times x minus h. So if we do h and k like that, like we have the h and the k, that's saying we're going to plug the center point in. And then the slope, whatever numbers we get, we just need to write the positive and the negative. So we're including both of these lines right here. So if we were thinking like this to write our equation for the asymptotes, we plug the hk in there, which is 0, 0, which is y minus 0 equals plus or minus something right there, x minus 0. Now you just have to find the rise and the run number. And so you can start anywhere you want. Like you can just start right here at the center point, then count up, which is 5. Hey, 5. Does that look familiar? That 5 right there? Oh yeah, right there. 5. And then I count right 3, which comes from that guy. And so we have 5 over 3, and that'll give us our slope. When we simplify it, we get y equals plus or minus 5 over 3 x. So instead of having to do all the work twice, like this, we can just do it once, like that. Alright, so those are our asymptotes. Once we have our asymptotes, you guys can draw your parabolas and use the asymptotes. Use the asymptotes as kind of like a boundary. That's why they're there. It's a limit. It's where the lines will never cross. And so there's my ugly asymptotes, and that works. I'm just missing one thing. What am I missing? Actually, technically 2 things. I'm missing a focus. So we need to know where our focus is. Now, is the focus going to count out this way and this way, like left and right, or is it going to count up and down for our horizontal hyperbola? Is it going to go up or down or left and right? It's going to go left and right because it has to be on the transversal axis, which is right here. The transversal axis connects the 2 vertices. And so I just need to know 1, 2, 3, 4. I just need to know how much I'm supposed to count out. Okay, so let's figure that out. And so to figure that out, we're going to do major squared plus minor squared equals f squared. Now we're using major and minor still just because, like I said before, we learned how to do the ellipse first, and it kind of like connects almost. You could think a squared plus b squared equals c squared, and c is what takes you to your focus point, a is what takes you to your vertex, and b is what takes you to your co-vertex. But it's totally up to you. I think most students kind of like this because it's like, oh yeah, I could kind of remember it better like that, and I'm down with that. You can think of it like that. And so, what is our major squared? What's our major squared? For this equation right here, what's our major squared?
9.
Yeah, it's 9, which is kind of weird because he's a smaller number. So our major is 9 because that's the first one. It's always going to be the first one for the hyperbola. And we're going to add 25, which is the minor squared right there, the 25, equals f squared. And 9 plus 25 is 34, which means we're not going to have a pretty f. The f is radical 34. Whoops. And radical 34 is going to be our distance, 1, 2, 3, I don't know, radical 34, to our focus point. But I need an approximate number so I can graph the focus point. What is radical square root of 34 approximately like?
6.
It is almost like 6, huh? But it's not quite 6 because square root of 36 would be 6. But 34 is a little below 36, and so it's got to be like 5 point something, right? 5.8 to be exact. So 1, 2, 3, 4, 5, and then a little bit. And so that's where I'm going to put my point. So focus. And then you got to count the other way. 1, 2, 3, 4, 5, and then a little bit. So I put my other focus right there. And that's everything that you need to know about hyperbola.